Alright, here's the first video for linear relations and functions. So in this one, we're going to identify linear functions and we're going to evaluate linear functions. So linear relations are just relations that have straight line graphs. In other words, they're ordered pairs whose graph, when you look at their pattern, is a straight line. Nonlinear, obviously, their graphs aren't linear, they're not lines. Linear equations and equations can be written in the form ax plus by equals c. And linear functions are a function whose points satisfy a linear relation. Alright, so remember linear equations, this is algebra 1 stuff, must only have exponents of 1 on x and y. So if it's got x, you're good. If it's got x squared, not good. That means not linear. Same goes for y. So they also must not have x and y multiplied together, and they must not have x or y appear in a denominator, an exponent, or inside a radical, which means a square root. For those of you that are like, radical, what's a radical? Alright, so identifying linear functions. State whether each function is a linear function and write yes or no. And then it says explain. We'll explain if it's no. So remember in the last video, function notation just means y. Looks like it's got an exponent of 1, they're not multiplied together, neither one's in a denominator as an exponent or inside a square root, so this would be yes. Alright, B, the issue is right here. This one is no, and it's because x is in the denominator. If it wasn't in the denominator, we'd be good. Alright, so here we have 3xy minus 4. The issue is here. So this one is also no. And this is because x and y are multiplied together. They weren't multiplied together and there was some other operation like addition or subtraction, we would be good. But they are, so we're not. Alright, last part, evaluating a linear function. So it says the growth rate of a sample of Bermuda grass is given by the function f of x equals 5.9x plus 3.25, where f of x is the total height in inches, x days after an initial measurement. So x days, so x is our days. How tall is the sample after 3 days? So we want to find f of 3. So that's 5.9 times 3 plus 3.25. So if at this point you want to use your calculator, go for it. So 5.9 times 3 plus 3.25. And it is 20.95. So this is going to be 20.95. I don't know, is it inches? Yeah, inches. So 20.95 inches after 3 days. Alright, so B, it says the term 3.25 in the function represents the height of the grass when it was initially measured. Alright, so the sample is how many times as tall after 3 days. So after 3 days, we're 20.95 inches. It was initially measured at 3.25 inches. So 20.95 divided by 3.25 gives me about 6.4. So it's about 6.4 times taller. Alright, so that's the end of this video. You can go ahead and complete the part 1 problem set and then watch part 2.